We're going to start today with Matt Timmins-Brown. He's still 14, or you're 15 now? 15 now. He's better known as the Raspberry Pi guy. Hasn't got the t-shirt on. And he's been producing videos on YouTube for a couple of years now. Very successful, over 1 million hits, or is it 2 million now? 1.5 million hits already from around the world. He's come today to talk to you about getting involved in Raspberry Pi robots, building Raspberry Pi robots, which he's been doing for some time himself. I'll let him talk about those all himself, so if we can welcome Matt Timmins-Brown. Give us a moment while we mic him up. Excuse me. I'll sort that out. Yep. Okay.
Hello. How do I get my PowerPoint to?
Technology, yes. Can't do this technology stuff.
You're not using a Pi, Matt.
Which one have you just plugged into? HDMI 2?
Yeah, I think so.
There we go.
Voila.
Right.
Okay. Hello, everybody.
In front of you.
Do I need to hold? Can people hear me?
Yeah.
Yeah. Okay. Cool.
Is it coming through the amp though?
Yeah.
Just.
Can you hear me at the back? Yeah. Okay. Excellent. So hello, everybody. Hello, everybody on the live stream as well. It's including my grandma. Hello. As Tim just said, my name's Matt, and I'm the Raspberry Pi guy. I do this in all my talks, so bear with me. Can you put your hand up if you've heard of me before? Ben hasn't heard of me. Okay, Ben, you've now heard of me. So yeah, as Tim just said, I'm 15, although I was 12 when I sort of started getting interested in computers and things, and I run a Raspberry Pi, primarily a Raspberry Pi YouTube channel on providing educational tutorials, videos, reviews, and I'm called the Raspberry Pi guy. That's me, that's my logo. To date, I've had around 1.5 million views and got about 30,000 subscribers. I'm currently 15, and so I'm going back to school on Monday, and I'm going to be starting my final year of GCSEs, which is going to be fun. Yeah, so don't hesitate to grab a business card later. Anyway, this is my YouTube channel. I'm sure it will be familiar to some. Yeah, check that out. So, on to what I'm going to be talking about today, which I've aptly named Robots. Who doesn't love them? So, now let me just point out something. Everybody loves robots. There's no one who doesn't not love robots. They're loved by men, women, boys, girls, all ages and all genders. And they are an excellent means of teaching computing. And why is this? This is because they make people excited. And they provide a hook that, in my experience, I haven't actually seen in anything else. The fact that you have a physical little robot is something that really captures people's imaginations. Okie dokie. But first, let me get this straight. What kind of robot am I talking about? So I'm not talking about the kind of robots that we see here. So before in a talk I had Cybermen and Dalek on here. They're cyborgs. Thanks for pointing that out, Jim. So we have the new Doctor Who baddie. That was an okay episode. We got HAL 9000, we got iRobot, Marvin. No, not those kind of robots. Not talking about those. I'm talking about hobbyist robots that are sort of two-wheeled little chaps like this, that are easily made and easily customizable and feature a Raspberry Pi at the heart. So one of my first robots was actually like this. Some of you probably heard this, a similar talk to this. He's called Dave. Dave died, but he was called Dave. And And yeah, he actually looked exactly like that. He had a chassis, he had a camera on the front, and he had a Raspberry Pi Model B. And so these kind of robots you can make for, say, around £30, and essentially all they are is just a bit of plastic, 2 motors, a motor controller board, and a Raspberry Pi. And they're really easy to make, as I've said multiple times now. Yeah. So with just, hold on 1 second. Okie dokie. So why are these kind of robots so useful in teaching computing? So sure, they're fun. You can make them trundle around on the floor. You can drive them places. You can spy on people with the camera. You can add sensors and all sorts. But isn't that just a load of fun? How does that actually teach people about computers and computer science? And how would, say, a school use this? Now, the reason why I like robots is the fact that they are an excellent way of teaching people about computing using stealth. People, when they use robots, they are learning about computer science, programming, electronics all the time without actually realizing that they're learning about it. And this is invaluable because when, I've said this before and I'll say it again, when you get taught computer science, or at least I've been taught computer science, I've been taught it in program finance applications which are painfully boring and just, they don't apply to you. You can't associate with them. Whether if you have your own robot, you can actually associate with that because it's your robot, you've made it, you've designed it, and it actually means something to you. And so I think that there are 6 key areas that robots address, 6 very important ones in terms of the computing curriculum, which is new, and also they're also cross-curricular with things like design. And these are the 6 computing concepts. So we have electronics. Electronics in the top left. This is probably the best thing that robots teach you about compared to, say, programming games, is the fact that you actually have physical electronics. You learn about things like circuits. You learn about how motors work. You learn that you need a motor controller board. You can't just control it directly from the Raspberry Pi. So you learn all about electronics. You learn how to wire things up. And this is a key. This is a key part of computing and a very interesting part. So some of the first stuff that hooked me into computer science and Raspberry Pi stuff was electronics. And some people might say, well, with just 2 motors, that's not going to keep people interested for long. And sure, it might not. But then, when you have a customizable robot platform like this, you can see that there's loads and loads and loads of space to add your own little things, like sensors, ultrasonic distance sensors. They can be added for the equivalent, for the grand sum of £3, and then you could make a robot with added functionality, such as the fact that it could avoid walls, etc. So there's a huge electronics aspect. The next 2 are engineering and design, and so these are a little bit cross-curricular. When you have a robot, quite a thing that lots of people like to do, especially when they're creating their first robot, is to actually design it and make it look pretty. So especially in, say, primary school education or sort of lower secondary school education, a key focus for robotics could be the actual designing of the chassis, the decoration, etc., naming it Dave, whatever. And yeah, so there's sort of the physical things on the top there, and then the more figurative things on the bottom, programming-wise. And these are loops, logical steps, and debugging. So a key computing concept, are loops. So while loops, for loops, these things they can be hard to get your head around, especially when say if you've got a computer program. Computer programs go through things very, very quickly, and so you can't really see things taking place in real time. And this can be quite hard to follow, especially if you're just learning about while loops and for loops. You don't quite understand them yet. However, if you have a 2-wheeled robot, you can actually see it take the steps of a loop logically. And so you could see that what better way to demonstrate a loop than to see your robot spin around and around and around forever. Next thing is logical steps. So as I said, computers go through things very quickly. Logical steps can be hard to see in a program which seems to be zipping here, 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 here. However, with a robot, with something like a predefined path, you want your robot to go forward for this long, you want it to go left, then you want to go forward, then you want to go right. You can see that there are logical steps in there. You can start to understand that a computer will go through things one by one logically. And finally, we have things like debugging. And debugging is another crucial aspect. And the fact that if you've got a problem with your program, you're going to need to debug it. And this can be quite off-putting for people who are just starting to program, if they've worked hard on this thing and then it's not working. But a great way to actually visualize a bug is to actually see your robot fail at something. So, as I said, if it's got a path and then it crashes into something, you can see that's a bug in your program and you can very easily change that. It's sort of an elementary introduction into things like debugging and logical steps. So, in terms of awesomeness, robots are great. And in terms of educational value, they're also very useful indeed. So it seems that, oh, hello, timing, whoops. Okay, yeah, I can bring this to a close. Robots are great for hooking people on computing, and they are also great for teaching people computing. Probably not got any time for any questions.
You do. You've got 5 minutes.
Oh, I've got 5 minutes for questions. Any questions? Yes, I saw that you have.
Well, having a Raspberry Pi robot, you could get in a classroom, it could be used to help kids with their problem solving. Like, you need this robot to get over a dispute. How can you make it do it? So maybe you could make some lifting device to lift something up and like build a rig.
Yeah, that's another a key thing that robots can help help people with is just visualizing problems and saying, just if a teacher, say in a classroom, said, I'd like you to make your robot do this, here's a problem. You've then got a physical problem that you have to get over, and that can be, as I said, a hook for students.
Just so we really butting in to that. One other interesting thing is I've just recently bought a robot arm thing, so they don't have to trundle around the floor. You get little arm things.
Thanks for the demonstration there, Jim. Yeah.
How does this fit in with the new curriculum that's just started this year for kids in the government pushing coding and programming? How can this be used in possibly the first thing? I think that's something that teachers are now having.
Yeah. So you code robots, but there are also, so coding can be, when someone first thinks of coding, they think of lines and lines and lines of boring text. As you go a bit deeper, you can see that it's quite creative. You have the creative aspects in games and things. But I think if you go even deeper, you can have a look at coding robots. And so I think a key aspect of robots is bringing computing off of the screen and onto the floor where it has wheels. And you can actually see it moving.
Can I answer that from a teacher point of view?
Yes.
My teacher Peter at a regional college. Matthew's got a really good slant on this where it is a very visual thing, but you could also take it from the point of view of learning about logic, learning about distant principles, acceleration and things like that. You have to code all of this stuff. So you're actually taking in a broad spectrum of the curriculum, not just your maths sort of stuff, your logic stuff, your puzzle analysis and things like that. You're also looking at physical computing as well. That's a big new thing with the new curriculum. So it's all of that.
One more question? Yeah? Any more questions?
Did they have a battery?
Yeah.
How do you cope with that?
So when you have a robot, or such a basic robot, let's flick back to this one. You have to power two things. You're going to have to power the Pi, and you're going to have to power the actual components, such as the motors. And the Pi can't really provide enough power for most motors. So these kind of sort of cheap Chinese motors, which are great for hobbyists, they run off about 6 volts. And so 4 AA batteries will suffice. And they normally can go into a motor controller board like the Ryan Tech MCB is my preferred one of choice. And then the Raspberry Pi itself takes micro USB as power, and so I found lots of people, myself included, just use an emergency mobile phone charger to power the Pi, and then maybe a Wi-Fi dongle in order to remotely interface into it. Any more questions?
I don't think we actually have any time for anymore.
Okay.
Because the motor controller board workshop is just about to start. So if there's anybody in here who's going to that, if you'd like to head out now, including Matt, who's
running
to do some of the training on that.